Good morning, dear students. How are you? I hope all are fine and safe at your houses. Okay, in yesterday class, I explained about J Thomson Atomic model and its limitations. Why J Thomson theory was failed? Mainly due to J Thomson unable to explain the stability of atom. So J Thomson theory was failed. If you didn't see J Thomson atomic model, then I'll keep in cards and as well as I'll give link in the description. You have to see. Okay, even though J Thomson theory was failed, but all scientists believed that J Thomson theory was correct until so many years. But one of the student of J Thomson, his name is Rutherford, got doubt on the J Thomson theory and he want to check J Thomson theory by using Rutherford alpha particle scattering experiment. Now let me discuss Rutherford alpha particle scattering experiment. Rutherford alpha particle scattering experiment. This is the diagram of Rutherford alpha particle scattering experiment. It is the alpha particle source. It can release alpha particles. It is the detector. Inside the detector, he placed one gold foil, and he arranged the gold foil in order to the alpha particle straightly strike out this gold foil. And on the walls of the detector, he applied the fluorescent material like ZNS, zinc sulfide. What is the use of zinc sulfide? When the alpha particles strike the detector, then automatically the ZNS, zinc sulfide, can glow. This is the use of fluorescent material. What is the daily life example for the fluorescent material? Do you know, students? This fluorescent material we observed in our daily life. In televisions, our televisions are there. I mean TV. In TV, when the light rays touches the TV screen, on the TV screen they applied fluorescent material. Then automatically it will appear the picture. That is the application of fluorescent material. Okay. Now here Rutherford sent 20,000 alpha particles onto the gold foil. Then Rutherford expectations like this will be: if J Thomson theory was correct, then any alpha particle, even one also, can't go into the gold foil. This is the Rutherford expectation. Why can't go? Because 20,000 alpha particles Rutherford sending onto the gold foil. Gold foil in the sense, inside the gold foil, gold atoms will be. Not only gold, anything, inside any matter, atoms will be. In the universe, how many atoms are there? For all the atoms, J Thomson theory applicable. Okay? It means all atoms have, according to J Thomson, all atoms have positive charges, more positive charges and less negative charges, more number of protons and less number of electrons, according to J Thomson. Okay, see, now Rutherford sending 20,000 alpha particles onto the gold foil, I mean gold atom, inside the gold foil, foil in the sense a small piece, gold foil, so many gold atoms are there. Now this 20,000 alpha particles is sending onto the gold atom. Then according to J Thomson, so many positive charges are there inside the atom. Then what is happening here? Alpha particles also consist positive charge. It having positive charge, and gold atom also having positive charge. Positive repulsions can occur. Then no alpha particle cannot penetrate into the gold atom. This is the expectation of Rutherford. But practically Rutherford what he observed. Now let me discuss. The observations of Rutherford. Okay, why Rutherford conducted alpha particle scattering experiment? Do you know? In order to check the J Thomson atomic model was correct or not. For that purpose, Rutherford conducted alpha particle scattering experiment. If no alpha particle cannot go into the gold foil, then Rutherford want to accept yes, J Thomson atomic model is correct. But like that not happen. What is happened here? During the gold foil experiment, 20,000 alpha particles Rutherford sent on to the gold foil. In that gold foil, I am considering one of the gold atom. This is the gold atom. Then out of 20,000 alpha particles, some of the alpha particles went straightly. Some of the alpha particles deflected like this. One of the alpha particle, exactly one of the alpha particle, one alpha particle struck in the middle and it reflected back. Only one of the alpha particle. So these three observations Rutherford observed. See, many alpha particles went straightly into the gold foil. Some of the alpha particles were deflected like this, deflected, went straightly, these are. And one of the alpha particle reflected back with 180 degrees out of 20,000 alpha particles. This alpha particle reflected with 180 degrees out of 20,000 alpha particles. These are the observations of Rutherford during the alpha particle scattering experiment. Now, based on this observations, Rutherford made some conclusions regarding atomic structure. Now, let me discuss the conclusions of Rutherford alpha particle experiment. What are the Rutherford conclusions? See, first conclusion is some of the alpha particles went straightly. It means most of the atom is empty. See, some of the alpha particles went straightly. So, most of the atom is empty. Why empty? For example, I am going in this way. Then here something object is there. Because of this object, I am unable to go further. So, I will go this side if possible. So here because of this object I am unable to go. If this object not there, then I will go. So here anything not there in the middle. So any object is not there to stop this alpha particles. So many alpha particles went straightly. It means most of the atom is empty. Out of 100%, 99% atom is empty. Remember this point. This is the first conclusion. Okay, next second conclusion is one of the alpha particle reflected back with 180 degrees. One of the alpha particle reflected back with 180 degrees. Why it reflected? We are sending He plus to alpha particle. It struck middle something and it reflected back. What is the something? That something should have positive charge. Why positive charge? We are sending He plus 2. It having positive charge. So middle also some positive charge existed. Because of this positive repulsions, it reflected back. Have you understood? So one of the alpha particle reflected back with 180 degrees. It means in the middle of the atom one positive charge existed. Okay, it is called nucleus. It means in the middle of the atom positive charge existed. It is called nucleus. Remember, and because of this nucleus, his theory is also called nuclear model. He only discovered the nucleus. So this theory is also called nuclear model. And if we observe properly, atom size is 10 power of minus 10 meters. Nucleus size is 10 power of minus 15 meters. Very small. Don't think 10 power of 10, not 10 power of plus 10. It is 10 power of minus 10. 10 power of minus 15, very small. We unable to see with our eyes, that much small. For understanding nucleus size as compared to atom, let me give one example. Let us imagine atom in the sense a big cricket stadium, and in that stadium nucleus is a small pebble, a small stone. Okay, atom is big stadium, in that nucleus is a small stone. That is the size of nucleus. Now you understood, maybe I am thinking about the size of the nucleus. Okay, next, third conclusion is some of the alpha particles were deflected many sides. See, one time alpha particle deflected this side, one time alpha particle deflected this side. Okay, it means sometimes based on the timings, the deflection of alpha particle is changing. See, here alpha particles are deflected this side. Why deflected? Here electrons are there, electrons are revolving. Because of this revolution of electrons, alpha particles are deflecting. When the electron is there here, alpha particle deflected this side. When the electron is there here, alpha particle reflected this side. Actually, if this electron not there here, then this alpha particle also can go straightly. But because of this electron, here electron having negative charge, alpha particle having positive charge. So positive negative attractions, because of this attractions, this alpha particle deflected. Remember this point. If this electron not there here, then this alpha particle also can go straightly. So what is the final conclusion? It means electrons are not rigid, not fixed. Electrons are moving with greater speed around the nucleus. Around the nucleus, electrons are revolving with greater speed. That's why we are observing deflection sometime here, sometime here, because of this revolution of electron. He compared his theory with the planets, solar system. See how the planets can revolve around the sun, like that only electrons also can revolve around the nucleus. So this theory is also called planetary model. So finally Rutherford alpha particle scattering experiment is also called nuclear model or planetary model. Remember. Okay, now let me discuss Rutherford alpha particle scattering experiment limitations, drawbacks. It is also called nuclear model or planetary model. This one you have to remember. Okay, see, according to Rutherford atomic model, it is the final structure of atom. It means the nucleus existed in the middle of the atom. It is nucleus. Remember, nucleus existed in the middle of the atom and the electrons are revolving around the nucleus with greater speed. Then where his theory failed, do you know? He told when the electrons are revolving around the nucleus with greater speed, then according to physics, when the moving particle continuously move, then automatically it will lose energy continuously and it will finally crash into the nucleus like spinal path. Okay, when the moving particle is continuously moving, then finally it will lose the energy and it will crash into the nucleus. If all the electrons are crashing into the nucleus, falling into the nucleus, then in the atom no electrons, only positive charge will be. Then again according to his theory, again atom is acquiring positive charge because no electrons. But we know very well atom is electrically neutral. So because of this rule, we can say his theory also failed. So Rutherford also unable to explain the stability of atom. It is the major limitation of Rutherford. Remember. Okay, his theory also failed. Actually this theory not failed. Still some improvement need. What he told, it is exactly correct. Improvement need. Because I will give more importance for the failures than the success. Because failure is the stepping stone of success. So if you fail in your life, no need to worry, we are very near to the success, remember. Okay dear students, today onwards I will give some quiz questions for you at the last of every video. Today quiz questions are, first question, I will give 4 questions. In that first question is, why Rutherford has taken only the gold foil in his alpha particle scattering experiment? Second question, what are the differences between mass and weight? How many electrons, protons, neutrons are there in Al+3 ion? Why? Fourth question, why we call H plus ion as proton? So these 4 questions answers, if you know, then comment in comment section. Okay, it is the today's class. If you like this video, then press the like button and please subscribe my channel. Thank you. All the best.